So what is f of a supposed to be? This is where you're starting. And f of b is going to be, this is how you end, or this is where you end up, finish. Okay, so what are we starting at?
We're starting at 1.
So you start at 1, but you don't start at 1, you're starting at x equals 1. What you actually start with is -4. So this, I'll write this, rewrite this in a step. This is f of 1, and this would be f of what? F of pi. Okay, let me erase this. I should have just moved it down. But what is f of 1?
4.
We know it's at -4, so you're really starting at -4. And what's happening is we're going to add some change. F prime, with all this stuff, says that f changes, and then after it changes for a period of time, 1 to pi, then you're going to end up somewhere. You're going to end up at f of pi, which is what I'm trying to find. So what I need to do is I need to find the total change in f by just finding the area under the curve right here.
Okay.
So how do we do that? At this point, you use calculator. All right, calculator. Find, what is it? How do I find it? Second trace.
Number 7.
Second trace pi.
7.
7 from 1 to pi?
No, T-O.
Just messing with you. Sabe jugando. So that's how much change there was that happened right here. So, so the total change is how much? Negative 2.382. So where do I end up? So I add those numbers. So I started at -4 here. Start at -4. Add a negative change of 2.382. That puts me at so that means f of pi. It's not that bad. Okay. And again, this is where I end up, or this is the finish. Yes.
Does the magnetic equation work for every single
Yes. It always works. Okay. Any questions? So that's the magic equation right here. F of b, fundamental theorem says that you, whoa, just making sure you're paying attention. So f of b says, the function at b. Where are you at b? Your fundamental theorem of calculus says that you are at f of a, where you start, plus total change from a to b. So all the stuff that happens or changes So again, this is where you start, and where you finish all depends on how much total change there was. Okay? What is that? That's a state. Isn't that a state? That's like Tennessee or something? United States? What is this? Texas?
Where's Florida?
Texas fell off the entire
Florida
state.
down.
Florida drowned.
Mr. Reed's down here like, Florida. Tip in the water.
Where's
Okay.
Michigan?
Michigan. Oh, the Michigan's that weird like.
Yeah. The lake.
Might as well just give it to Canada. All right, so let's look at this. Let's look at these questions. What does this say right here? Regions A, B, and C in this figure above are bounded by the graph of the function f and the x-axis. If the area of each region is 2, find each of the following. So we don't need to calculate it, and we don't need to use the calculator to find these areas. They are all equal to 2. Even though they're all funny shaped, they're all equal to 2. Okay, you just gotta believe. You gotta have faith. So find each of the following. What is this going to equal?
F3 F3 negative 3 is 2
Can we rewrite it?
plus 2. I mean plus 2 plus the total change.
Say that again.
Wait, f of 3 equals f negative 3 plus 2.
Isn't
But,
that
negative-
just 6?
No, plus 4. Plus 2 plus 2.
Okay, so here's something we didn't really talk about. This is area 2, right?
And 2 and 2.
They're all 2.
But down here, what kind of triangles we have? Or rectangles we have?
Either way is 2.
They're negative. So down here, the area of A is a negative 2. And down here, C is negative 2 also. So these two areas cancel each other out from negative 3 to 0.
Where are you getting these negative? Is it just because it's under the x?
Yes. So let's analyze this again. If I have a function
Equals
like this,
negative
okay, this is f, then remember the rectangles we were making?
Yes.
It's dx times f of x. But f of x, is that positive or negative here?
It's positive.
This one's positive, so this one's going to have a positive area. But if it went below the axis, and I had to find an area here, look at the rectangle. You have dx, but then is f of x positive or negative here? It's negative, so areas below are negative. Areas above are positive. And that change cancels each other out, because, or sometimes, if it's equal. Because, do you remember in physics when we talked about, oh, you have positive velocity, you have negative velocity. Positive velocity, you go one direction, what does negative velocity do? You go the opposite direction. And so you undo any movement you've done, any movement that you you went in the positive direction. Okay.
It'll be F. Because it's all
Okay. So here, I might even rewrite this just so that maybe this makes more sense. So this area right here, starting from -3 going all the way to 3, you start with -2. Then what happens?
You go to positive
Then you add 2, that's how much change just happened. But then you
and go away.
subtract 2 also. So these two cancel each other out and you're left with
So that's your change.
-2. Because you were changing in the negative direction, then you had some positive change, then you had negative change again. And some of the change cancels out completely. What do you think this means?
Only like the B.
So it's gonna
So -2 positive 2 plus 2 will be 6.
So all the areas with this absolute value tell you that all the areas are positive. So this is just going to be 2 plus 2 plus 2. That equals 6. What do you think happens here?
Six.
-1, 3, and
It's just like this one, right? It's the same thing as -2, but then you have this plus 1. Okay? Plus 1 is a constant graph. So let's think about this. If I have a constant graph, and the height is 1. And if I'm going from -3 to 3, how much area under the curve is this? How do you get that?
the 6, 6, and then 1.
Because the height is 1, and then this distance is 6. So this is simply -2 plus 6. So did anybody get that?
So the 1 is considered like the whole entire equation?
That whole rectangle.
Yeah, when you see a 1, it's like a constant function. So instead of something curvy like this, you get just a line. And you're only finding the area from where to where? From -3 to 3. So that means the area is just 6 times 1, because that's the height.
So the height's only going to be 1?
If it says plus 1.
Oh.
So in this case, the next case might help clear things up. What's this graph going to look like, the plus k? It's going to be very similar, except
Instead of 1?
it's going to be just k. So if this is k, and I'm finding from where to where?
3 to 3.
So what's the area going to be here?
No, you don't know.
Well, what's the height?
K.
And what's the width? 6.
6.
So the area here is, so this is going to be -2 plus 6k. Yes?
I have a question for Steve. Like, how come you just can't get the value of each from